Assalamualaikum and hi everyone. In this video, I will explain how to solve problems regarding buffer solution. I am Madam Nurul Hidayah from College Matrikulasi Pahang. First, let's recap the definition for buffer solution. It is a solution which has the ability to maintain its pH when a small amount of strong acid or strong base is added to the solution. Let's look at acidic buffer. It is a solution which contains weak acid and its salt, which is also the conjugate base. The formula to find pH of acidic buffer solution is pH equals to pKa plus log concentration of conjugate base over the concentration of weak acid. An example of acidic buffer solution is a solution containing ethanoic acid CH3COOH and sodium ethanoate CH3COO. There are also many other examples. For example, we have HCN and NaCN, benzoic acid and sodium benzoate, and many more. Now let's look at what happens when we add strong acid to a buffer solution. So strong acid is H+. So acid will react with conjugate base. So in this solution, the conjugate base is CH3COO-. CH3COO- actually comes from CH3COO-Na. So this the dissociation of CH3COO-Na will produce CH3COO- and Na+. These are all in aqueous form. So CH3COOH, which is the conjugate base, will react with the H+ added. So plus H+. So this reaction will produce CH3COOH. When a strong base is added, so strong base is OH-. So base will react with the weak acid present in the buffer solution. So the weak acid in this buffer solution is CH3COOH. So it will react with the OH- added. This reaction will produce CH3COO- and H2O. Now let's look at example 9 in page 208. The pH of an acetate buffer, that is a mixture of 0.05 molar acetic acid, 0.05 molar sodium acetate. So the pH given is 4.75. Calculate the pH when 0.01 mol of HCl is added to a liter of solution, assuming that the volume increase upon adding HCl is negligible. So we assume that there is no volume change after we add H+ into the buffer solution. So now let's draw. This example so that you can understand better. So in this beaker, where the volume is 1 liter, there is 0.05 molar CH3COOH and 0.05 molar CH3COO-Na. The pH given is 4.75. Now after adding H+, 0.001 mol of H+, we want to calculate the pH change. So to solve problems after the addition of H plus or OH minus, you have to construct ice table so that we can calculate the changes in the concentration after the H plus added is completely eliminated. So now you have to write the equation involved. So H plus will react with the conjugate base and it will produce CH3COOH. Next, you have to calculate the concentration of the H plus added. So 0.001 mole divided with 1 liter. So this is the volume of solution. So we have 0.001 molar. Next, you have to construct ice table by using the equation in step 1. So we have H plus, where the concentration is 0.001 molar. CH3COO minus, the concentration is 0.05 molar. And CH3COOH, the concentration is 0.05 molar. So for the change, we have to completely eliminate the H plus added. So for the reactant, it will decrease by the concentration of H plus. So minus 0.001 for H plus. So we will get 0 in the end. For CH3COO minus, 0.05 minus 0.001. So you will get 0.049 molar. While for CH3COOH, it will increase by 0.001. So this one will become 0.051 molar. Now we have the new concentration of both acid and the conjugate base. Now we just have to insert the new concentration into the equation for the buffer solution. So the Ka is given. So just insert the new concentration. So we have 0.049 for the conjugate base. And for the weak acid, we have 0.051. So after calculation, you will get 4.74. So as we can see here, the initial pH of buffer solution is 4.75. But after addition of H plus, the pH is now 4.74. So we can see here the pH does not change much. The pH only decreased by 0.01. So this is what we call as buffer solution, where the solution will maintain its pH even though we add small amount of strong acid or small amount of strong base into the solution. Now let's look at basic buffer. So a basic buffer solution consists of weak base and its salt, which is the conjugate acid. So for basic buffer solution, you will calculate the pOH and pKb plus log conjugate acid over the concentration of weak base. So if you have to calculate the pH, so just subtract by 14. So you will find the pH. So an example of basic buffer solution is a solution containing ammonia, which is NH3 and NH4Cl. Now let's look at the equation when strong acid is added. So strong acid is a H plus. So strong acid will react with base. So H plus added will react with the weak base in the solution. So it will form NH4 plus. When strong base is added, we have OH minus. So OH minus will react with the conjugate acid. So in this solution, the conjugate acid is NH4 plus. So it will form NH3 and H2O. Now let's look at example 10. This is in page 209. A buffer solution is prepared by mixing 400 ml of 1.5 molar NH4Cl solution with 600 ml of 0.1 molar NH3. For question A, you have to calculate the pH of buffer solution. So, let's draw the example here so that we can understand better. So, we have 1.5 molar NH4Cl and the volume is 400 ml. Then we have 0.1 molar NH3 where the volume is 600 ml. So the volume of solution will become 1 liter. 400 plus 600, the volume is 1 liter. So you have to find the new concentration for NH3 and NH4Cl before you insert into the formula. So first, kita cari number of mole in NH4Cl and also ammonia. So this is from formula molarity equals to mole per volume in liter. Okay, so dari sini dia dapatkan mole lah. So for NH4Cl and ammonia, so you will get 0.6 mole for NH4Cl and 0.06 mole for ammonia. Then find the new concentration by dividing the number of mole with volume in liter, which is 1 liter. So you will get 0.6 molar for NH4Cl and 0.06 molar for NH3. Okay, ataupun kita boleh guna kaedah lain. Ini sebenarnya melibatkan dilution sebab initial molarity dia adalah 1.5 and then the molarity changes when the volume changes. So we can also use M1V1 equals to M2V2. So sama je lah. Untuk NH4Cl, the initial molarity is 1.5. The initial volume is 400. Then we need to find the new molarity when the volume changes to 1000 ml. So the molarity will become 0.6 molar. So do the same thing for ammonia, sama je. So the initial molarity for ammonia is 0.1. The initial volume is 600 ml. Then we need to find the new molarity when the volume changes to 1000 ml. So you will still end up with the same answer. So you will get 0.06 molar. So sama je lah. Now find the pH by finding pOH first because this is basic buffer. So the formula is pKb plus log concentration of salt over the concentration of weak base. Insert all the values into the equation given, the value of Kb in the question. Then insert the new concentration for the salt and the base. Then you will get 5.74. To find the pH, just subtract by 14, so you will get 8.26. So this is for question A. Next we go to question B1. How the pH changes when 0.15 molar of NaOH is added. We have to assume, in the example, it is stated that we have to assume that the volume of solution does not change when HCl and NaOH is added. So kat sini kita assume tak ada perubahan volume. So we just assume that the number of mole of NaOH react is the same as the concentration. Kita terus assume macam tu lah. So first, you have to identify the equation involved for the reaction. So OH minus, which is base, will react with the acid in the buffer solution. So we have conjugate acid, which is NH4+. So this reaction will produce NH3 and H2O. Now just construct the ice table. So just write the concentration of NH4+ present in the buffer solution from question A and the concentration of ammonia from question A. So this is the initial concentration of the buffer solution. So we have 0.15 molar of NaOH. Okay, so kita akan tolakkan dengan 0.15 molar sebab untuk buffer solution, the strong acid and strong base added into the solution akan eliminate completely. So tolak dengan 0.15 molar. So do the same thing for NH4+ because reactant always decrease and product will always increase, okay, by the number of mol yang kita nak hapuskan tu tadilah. Okay, so finally OH- akan jadi kosong lah sebab kita memang akan hapuskan OH- tu sepenuhnya. It will react completely with NH4+ in the solution. So lepas kita tolakkan 0.6 minus 0.15, so you will get 0.45 molar. For ammonia, we have 0.06 plus 0.15, so you will get 0.21. Okay, now just insert the new concentration of NH4+ and also NH3 into the Henderson-Hasselbalch equation. So you will get POH is 5.08. To find the pH, just subtract by 14 and you will get 8.92. So that's for 13B1. For 13B2, how the pH changes when 0.011 molar of HCl is added. So first identify H+ will react with which component of the buffer solution. So H+ is acid. So it will react with base in the buffer solution. So the base in this buffer solution is NH3. So this reaction will produce NH4+ aqueous. Okay, so you have to construct ice table so that we get the new concentration after H+ is added into the solution so that we can insert the new values into the Henderson-Hasselbalch equation. So initially in the buffer solution we have 0.06 molar of NH3 and 0.6 molar of NH4+. Now by adding 0.011 molar of H+, so we have to subtract 0.011 molar of H+ added so that we get 0 in the end. For NH3, we will subtract by the concentration of H+, so we will get 0.049 molar. And for NH4+, add 0.011 molar, so you will get 0.611 molar. So keep in mind, reactant always decrease and product always increase. Now we have the new concentration. So just insert the new concentration into the Henderson-Hasselbalch equation. Then you will get 5.84. So to find the pH, just subtract by 14 and you will get 8.16. Thank you for watching.